So basically we're cross multiplying, right? You take the two numbers that are on a diagonal and you multiply them together. So 9 times 8 is 72. And then you take the next two numbers that are on the other diagonal and you do equals 3v. You solve that by dividing by 3 and dividing by 3, and then v equals 24, right? Same thing here. You take one of the diagonals and you multiply them. 7 times 8 is 56. This is where it gets a little more complicated because we've got to do some extra algebra, right? We've got to distribute. So I've got 10 times n minus 5. Remember, you got to distribute that 10 over everything inside the parentheses. Hopefully your algebra teachers did a great job of teaching you that. So 56 equals 10n minus 50. Then we're going to add 50 to both sides. And I'm just going to move over here so I have more room. 10n equals 106. So n equals 10.6. If I get something crazy that you didn't get, let me know, okay? Questions on that so far? I'm watching the chat. So if I come down here, 10n equals 6 times n minus 9. We're going to distribute. So 10n equals 6n minus, is that 54? Subtract 6n from both sides. I'm running out of room, so I'm not going to show all my work. 4n equals negative 54. That negative is important to keep once you move the 6n. And then n equals negative 9. Normally, I don't like negative numbers in geometry, so I would always test that number, plug it back into whatever you're finding. You can't have a negative length side or a negative angle, so you always want to plug your negative numbers in and make sure they really work. The next one is just a stamina problem, right? We're just trying to practice some algebra here in geometry. So 7 times v plus 3. And then I go to my other side, 2 times v plus 1. Oops, not plus 1, minus 1. That green is so hard to see. Let me change that to a different color. So then I get 7v plus 21 equals 2v minus 2. Subtract the 2v from both sides, and I get 5v. And then add the 20 or subtract the 21 from both sides, and I get 23. And then we get v equals 23 divided by 5. Decimals kind of freak me out a little bit too, so I would definitely put that in my calculator, make it a decimal, and then double check it in whatever I was doing, okay? Questions on proportions? Do we feel okay about that? Can I get a thumbs up, thumbs down? Positive, yes, no, maybe so. Are we all still awake?
Yes.
Okay. So our task for today is to talk about similar. All last week we talked about congruent triangles. Congruent had a symbol that looked like that, and we had 5 ways of proving triangles congruent. We had side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg, okay? And our symbol looked like this. It had the equal sign with the squiggle. Everything had to be exactly the same. We could set things equal. We could find missing angles. We could do all kinds of stuff, right? So now we're talking about similar. How is similar different than congruent?
Because they look the same, but they're not the same.
Exactly. So this is kind of like when we dilated in the transformation unit. We made things bigger and smaller. So it is the same shape, right? I've got 2 little wiggle worms there, but they are different sizes. One is small and one is large. And we've got a different symbol in there. I know that's super tiny. Let's see if I can make that bigger. So my symbol here is just the one squiggle without the equal sign on it, okay? Corresponding angles are going to be congruent. So we can still set angles equal to each other. but sides are going to be proportional. So we're going to have to set up two equal fractions to show that they're equal. So we're going to have 4 sets of sides instead of just one, which means we can't do angle side angle and we can't do angle angle side because those only have one set of sides and we need 2 sets of sides in order to make a proportion. Okay. Let me erase this because I don't know if my Screencastify is going to get smart and take everything with me. So if we look here for similarity statements, notice what's different. I've got a similar symbol instead of a congruent symbol, but all my angles are the same. So the one looped angle is exactly the same as the one looped angle, and the two looped angle is exactly the same as the two looped angle. And then the 3 looped angles are exactly the same too, right? All of these are exactly the same, whether it says similar or congruent. The difference is the sides. So the difference is over here with the sides. I can make a proportion with the small sides and the medium sides, or I can make a proportion with the medium sides and the large sides, but we got to have 4 sides. We've got to have JK, which is here in yellow, goes with PM, which is here in yellow. We've got to have KL. KL is in green, and it goes with MN, which is in green. And then JL, which is the medium side and the medium side, right? So I've stacked them. I've got yellow on top of yellow, green on top of green, and blue on top of blue. All of my JKL sides from this first triangle are all on the numerator. And all of my NPM sides are all on the denominator. So my small triangles on the top, my big triangles on the bottom, and I've matched up all the sides. There's a lot of organization that comes into play here, okay? And there is a video. I encourage you to watch the video, especially if you're confused. Miss Kimbrough makes most of the videos. She's phenomenal. I love her. Would not teach at Kempsville without her. So finding missing measures, you match the corresponding sides. We've been doing that. So yellow goes with yellow, green goes with green, and we find that from the key up here, right? So we could even add pink goes with pink because AC is the first and the last, and DF is the first and the last, right? Then I've got the X from the small triangle on the top, and it goes with the 28 because they're in the same triangle. Both of those are in the same triangle, the small triangle. And then I've got the yellow side that goes with the yellow side and the green side that goes with the green side. And both of them are in the big triangle. Okay, so small is on top and large is on the bottom. And you got to match up the sides. Setting that proportion up is the hardest part, okay? Once you set up the proportion, you are golden because everybody is good at doing proportions, right? But this is the hardest part, and that's what we're going to practice literally for the rest of the week. So here, same thing. If 2 figures are similar and we have a scale factor, right? You just put the scale factor into the proportion. So 2 to 3 becomes 2 over 3, 2/3. We put the 2 with the small thing. So the 2 goes with the smaller number, the smaller shape, and the 3 goes with the bigger number, the bigger shape. And then we cross multiply. 3 times 42 is 126, and 2 times x is 2x, and then we solve. Okay. I think we're going to go ahead and look at the third slide, and I'm just going to give you all the information right up front. I know you're probably trying to fall asleep on me. Resist the urge. right? We had 5 ways of proving congruent, but 2 of them go away. So we only have 3 ways of proving similar. So it's a little bit easier in that respect. We've got angle, side, angle. Angle, angle, period, no sides. Because if I have 2 angles, then can I calculate the third? And angles are always congruent. This is the easiest way. I love this one. This is absolutely my favorite. You've got 2 angles that are congruent in 2 sets of triangles. Then those triangles are similar 100% of the time. Okay. The next one is side, side, side. This is my least favorite because it's the most amount of work. Blah. You've got to have 3 sets of proportions. So we've got to do small, right? 3 and 6. We can make a fraction. We can reduce that fraction. So all we're doing is reducing. And then we've got to do medium and medium. And we reduce that fraction. And then we do large and large. So large and large. And we reduce that fraction. Okay, so we're going to do 3 sets of fractions, find the decimals or the fractions, and make sure that they're all congruent. Okay. Last one is side, angle, side. Side, angle, side is kind of a combination between the 2. Okay. You make a ratio of your first side. You make a ratio of your second side. So all you have to do is do 2 of those and match some kind of angle. Okay, and the angle has to be in between. So if I'm going around this, I have a side and then an angle and then another side. We got a side and then an angle and then another side. Okay, are we still awake? Maybe, kind of, sort of, hopefully.
Yes.
Okay. If this is confusing and I've lost you, you tuned out and realized a minute later that I moved on to 17 other things, there is a video here. Watch the video, okay? They really do help. So what I want you to do in your notebook is write a quick summary of what you've learned, okay? So what are some of the key pieces? We need to know the difference between this symbol and this symbol. What's the difference between those 2 symbols? Yeah. You don't have that in your notebook? Oh, no. I'm going to put a copy of this in the chat box. You should be able to open it, make a copy of those slides, and then add them into your notebook, whatever's missing. Does that link work? It looks like it. Lots of people are joining me. So make a copy of that. You can go over in the left. So once you have it open, you can click on whichever slides you need, then right click on it, copy them, and then go into yours and paste them in at the bottom. So again, what I did was I went to the slides that I just sent you, made a copy of them. So just highlight them. And you can do Control click to highlight them. Then do Control C to copy. I'm on a PC, not a Mac, or not a Chromebook. And then come over here and do Control V to paste them in. And then you'll have all the slides in one spot. Did that work? Or you can save them later. But you do need to make your own copy. So know that that symbol is similar. This one is congruent. We can do side, 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 or angle, angle for similar. Those are the only 3 choices. And then congruent has 5 choices. Side, 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 angle, side, angle, 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 side, and hypotenuse leg. And then the last thing you need to know here is angles are always congruent. And then sides change. If they're similar, they're proportional. And if they're congruent, then they're congruent. Okay. Questions on those? So the first thing I'm going to do is look and see what I've got. I've got a small side, and I've got a small side. So those are going to go together because 5 is the smallest number in the LMN triangle, and 12.5 is the smallest number in the 12.5, 15, 20 triangle. So the small sides go together. Then I've got a medium side, that's the 6, and a medium side, that's the 15. And then last set, I've got a large side, which is the 8, and a large side, which is the 20. What am I given there, sides or angles? Not a trick question. Am I given sides or angles?
Sides.
Sides. So it's definitely not going to be angle, angle. So I can eliminate that answer choice off the bat. It's also not going to be side, angle, side because I need an angle for side, angle, side, and I have no angles here. Okay. So it's either going to be side, 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 or not. So then I've got to put my numbers together. So I take my small sides and I do 5 over 12.5. 5 over 12.5. What is 5 divided by 12.5 as a decimal? Anybody got a calculator?
0.4.
0.4, perfect. So then I go to my medium sides. And if I started with the 5, I got to start with the 6. So 6 over 15. What's 6 over 15 as a decimal?
0.4.
0.4. So just like in A1 on the homework, we've got, oh, I need the large sides now. Oh, I messed up my color coding. So then I've got large sides. The 8 goes on top because I'm doing small over large. And what's 8 over 20? Is that also 0.4?
At this point, probably.
Probably, but I probably should check because you know geometry is tricky, tricky, tricky. They're always trying to trick you into thinking something that's not true. 0.4. If all of these decimals are equal, then all of my ratios are equal. So this, my friends, is side, side, side. Okay. It's a lot of work, but it's not really difficult work. It's just kind of a lot of it. And you can get it down to a 50-50 just looking at what you're given. Questions on that first one? Is everybody on the Pear deck? The link worked?
Yeah, but it's like a Google slide.
Oh, is it a Google slide? The Pear Deck didn't start?
Mm-mm.
Oh. Let's do this one then. Is that the link to the Pear Deck? So you can write on it?
Yeah.
Now we've got people there. So I'll give you a second to put this information into the Pear Deck on slide 2. And then we'll go to slide 3. And if you're already done with slide 2, feel free to go ahead and go on to slide 3. Make sure you eliminate all the choices that can't possibly be right first, and then go on to the next. Trying to prove it. I feel like I lost about 4 people. Maybe they fell asleep. We all need to sing, maybe.
Not this early in the morning.
I would agree with that. So I'm going to go to slide 3. What should I mark? Sides. Yeah, I think that's great. So I've got 2 congruent sides on this one. Do I have 2 congruent sides on the other one? I do not. So automatically I can tell my sides are not going to be proportional. So it can't be side, 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 and it can't be side, angle, side. The only angle that I can mark is going to be the vertical angle. So I definitely do have vertical angles. Do I have any other angles? Nope. So it can't be angle, angle either. So guess what? Boom. A quarter of these problems are going to be not similar. So if you get not similar, that's okay. That is a valid choice. Okay. So we had side, side, side here, and we just figured out which sides corresponded to each other, did the math to find the equal decimals, and did side, side, side. Here, it'd be tempting to do side, angle, side, but I have an isosceles triangle on the right side and a not isosceles triangle on the left side. Or at least I don't know if I do. Maybe there is another side over here that's a 40 or 39. I just don't know. So let's look at number 4. Number 4 starts with the tricky ones. What do these arrows mean? Parallel. Those mean parallel. When you see parallel lines, I automatically want you to think alternate interior angles and corresponding angles. Okay. So I can make a Z, parallel, transversal, parallel. So angle A and angle E are congruent, right? Angle A is congruent to angle E. So I have one set of angles. Then I can go the other direction and go parallel line, transversal, parallel line, and angle B is congruent to angle D. Angle B is congruent to angle D. So, ha! Is there another set of angles that I can mark? Can I always mark vertical angles? Yes, I can always mark vertical angles. So angle ACD is congruent to angle ECB. What is my answer choice over on the right-hand side? Angle, angle. Try 5, 6, and 7. I'm going to stop sharing. Problem, right? So let's look at 7. Do I have a brave volunteer to tell me what I need to match up? What's the first pair of numbers that match up?
I always think the first thing you can actually see is that the vertical angles.
Absolutely. We definitely can do vertical angles right there. So I have a pair of angles. So I can do an angle or an angle. What else can I look at? What's the smallest side in the purple triangle?
6.
6. So if we label them small, medium, and large, I can do 6. And then what's the medium side? Again, in the purple triangle. 12. Which leaves the 24 for the last one. So this is one way that I organize them sometimes. Let's do red. So then I go to this other triangle. And what's the small side in the red triangle?
5.
5. And the medium?
10.
And that leaves 20 for the large, right? Just divide straight down. Everybody take one fraction and put it in the calculator. Take one fraction and put it in the calculator. And what do you get? Everybody, all at once. What'd you get for a decimal?
1.2.
1.2. Victoria, which fraction did you do?
6 over 5.
That's the one I did too. But I think we're going to get 1.2 for all of them. We only have one set of angles, so it can't be angle, angle. The 5 goes with the 6, and the 10 goes with the 12, and the 20 goes with the 24, and they all do the same thing. So we can either say side, 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 or because Victoria, you're so smart, and you saw those vertical angles, we could say side, angle, side. So either one of those are valid. You just need to have the angle marked if you're going to say side, angle, side. Okay. I'm going to stop sharing.